Let's first talk about the once routines in iPhone. However, I would suggest not to be confused with the static methods in Java. They do share some similarity, but they're also different. So I would suggest try to learn it from scratch about once routines. So let me syntactically, what you would do is, let's say this particular routine, which is going to return a new array. So that one there, simply say do. So that's the normal routine you will do, the non-once routine, the normal one. On the other hand, you can also change the keyword here from do into once. So that's the second keyword you have to learn in this lecture here. Remember, we learned about expanded before. Now there's another keyword, once, you have to learn. Okay, so now let me switch the iPad and tell you what the difference really is between a once routine versus a normal routine. Now let's switch to the iPad to actually see how the program works. So let's focus on the normal routine just as a quick review on how they should behave. So let's say here we're going to focus on this particular new array routine, which takes an input string, returns an array, and then we'll simply first of all create the array to be empty to begin with, and then we'll simply just try to, whenever you call this with the input string s, we'll simply insert the string into the end of the array by using force. Okay, very simple one. Why don't we take a look at how this should behave, and then we'll contrast that with the once version later. Okay, let's now try to start from here. First of all, we are trying to we declare a to be of type A. So A is this particular class where we have this new array. And then we got array 1 and array 2 of type array of string. Okay, let's now, first of all, we create an object called A. So A is simple. Well, this one is not that important, but I'll just draw that anyway. A of type A. And then, so here we say array number 1 is going to be A the new array Alan. Okay, so that means we're calling the new array over here with the first string, which will be Alan. That's what we're doing, right? So what you would do is simply going to create an array over here. So it's going to create an array that's initially empty, and then it's going to force into that particular array to the end, right? And then we're going to force just Alan over here. So now we're going to get Alan. So index 1, and then it's going to point to Alan. Okay, so now you can think about this particular array is going to be the return value, right? You can think about just return this particular address of the array. And then once we get it, we're going to assign that to ARR1. Okay, so eventually this is going to be ARR1. So that is the array. And then if you try to do some assertion checks, you can see ARR1 the count is equals to 1. That is okay. Just one element here. And also ARR1 at position 1 should be the same as Alan, right? Exactly Alan over here. So far so good. Let's try the second call to the array, new array or routine. So let's say here we got ARR2 is going to store the return value from the second call to the new array. Notice that this is the first call, and this is the second call. For a normal routine, doesn't matter which call you're making that, because you will simply just execute the same block of code. However, later on we'll see, in the case of the once routine, the first call matters compared with the rest of the call, all the subsequent call. We'll see. So now AR2 is going to be, okay, we're just calling the new array for the second time, now with mark. So mark is going to be the second argument we're going to do, and then what you will do is very similar to before. We'll simply create an empty array from the first line, and then we're just going to force to the end, right? So that means we're going to have an array, a new array, different array. 1 over here, and then it's going to point to mark. And then the return value is going to be stored into ARR2. So that means ARR2 is now going to point to this particular array, the beginning of that. So now if we say ARR2, the count is equal to 1, that's actually true, right? Only one element here. And also ARR2 1 is pointing to mark, and that's also true. Okay, so far so good. And now the most important assertion to look at will be, let's say we simply want to say ARR1 equals ARR2. It seems to be a no-brainer because it's simply ARR1 and ARR2 simply represents the return values by two separate calls to the same routine. In which case, because every time the first line is simply just to create a new array object, so it's guaranteed the return value from the first call should be a different object from the return value from the second call. In this case, if you're trying to use address comparison, In that case, it should be different. Okay, so that's why I say not over here. So just this expression over here is going to be false, and then we say not false is going to be true. So this is also going to pass over here, this assertion here. Right? So it's a very quick summary of how a normal routine that's not once is going to behave. So now let's switch the context to we only change the word from do into once over here. So that's what we don't see, how the behavior is going to be different. Okay, let's take a look. So now let's switch to the second test we want to do. So now we want to focus on this once routine. So this is the routine we want to talk about, the new once array over here. And then it's also going to take an input string and also return an array of string. And then the first line will still be to create an empty array over here, and then it's going to force whatever the input string it is to the end of the array. Okay, the same as before. The only difference is we're using once over here. Let's now take a look at the test over here, which is a different test. And we still got A here. I'm just going to omit the A this time. And then we got ARR1 and ARR2. Okay, but now we're just calling different routine over here. Now we're calling this particular new once array. Okay, let's see what's going to happen. If you're calling a routine that's declared to be once, basically you have to distinguish between, okay, whenever you talk about a once routine, basically you have to think about the very first call versus all subsequent call. Whereas the all subsequent, the second, the third, and the fourth doesn't matter. Just anything that's not the first. All subsequent call. Okay, you have to distinguish between these. So this will behave differently from all the others. Okay, let's see how exactly. So now, if you try to call the new once array for the very first time, right? This is the very first call. Whereas this particular one is the subsequent call. Okay, let's see what happened to the first call. For the very first call, you're still going to execute like a normal routine, in which case you're going to create an empty array over here, and also you're going to insert to the end of the array. So these two lines will just be executed like a normal routine, just for the very first call. So what you would do is you're going to create an empty array and then force. So now we have Alan over here. So for the first one, it's going to be Alan. Okay, and then, so this is going to point to Alan. And then it's going to be stored into ARR1. So ARR1 is now pointing to this particular array of size 1. So now if you try to check the assertions, ARR1, the count will be equal to 1. That's true, only one element here. And also ARR1, tell the Alan is true because it's really pointing to Alan. So this is no problem. So this particular one is going to be check. Okay. So what about the second call? Basically all the subsequent call following the first call. What's going to happen is this. You can imagine that under the hood, okay, because the return value from the very first one is this particular array, you can think about there is some temporary variable that's actually declared behind the scene. You don't really see this variable over here, but this is actually created that's actually going to point to this particular array over here. Okay, so the temp. This is maintained by the IFO runtime. You're gonna keep it. Okay, and now let's see what's gonna happen when we call the new once array the second time. Okay, because the system will keep track of how many whether this is the first time or all the subsequent times of call. So now you're calling this a second time. What you will do is, even though you're calling with mark, however, you can think about for the once routine, the input argument here only matters just for the first time, only for the first call. Starting from the second call, the input argument doesn't really matter. That's why usually for once routine, as we'll see how we use it in the singleton pattern, you don't typically put any input arguments. I put it here just to show you that the input argument will just be ignored starting from the second call. Okay, that's the principle. So now what's going to happen is, because it's once, and also you're calling this for not the first time. So what you will do is, you will simply just return this particular reference over here, rather than executing the body of the implementation. It will simply just be bypassed. So what you will do is, so now ARR2 over here is just going to point to the same all objects as temp is pointing to, or as ARR1 is pointing to. So think about, if you try to do a once routine that actually returns something, it always returns to you the same object reference, the same. Okay, it never changes. So now, in this case, if you try to see do this, ARR1 the count equals 1. Yeah, ARR2 the count equals 1. Yeah, it's only there's only one element here. It's the same array basically. And also ARR1 would be at position 1 should just be Alan, not Mark, right? That's a critical difference because you're still pointing to the same array over here, the same array, just the same. So that's why it's still Alan. So this one, Alan, will just be true. Okay. So now finally, you can see that if you say ARR1 and ARR2, are they pointing to the same objects? The answer is yes, because you can see ARR1 is pointing to this particular object here. ARR2 is pointing to this particular object, so the same object. So that's the critical property for the once routine that returns something. Okay, so this one here will just be true. Okay, so that's about really the difference between once routine and the non-once routine. So for the once routine, what really matters is for the very first call, which is going to execute the body of the implementation just for the first call. After that, all the subsequent calls are just going to get whatever reference you have cached under the hood. Just return the reference. So there's no computational cost for the once routine starting from the second call. That's the difference you have to pay attention to. Okay, let's go back to the slides. And then there's a summary. These are the two test cases that we talk about. Test the normal query versus test the once query. So we already explained them. So this is the general form for the once routine. As I said before, do rather than once. And you will typically not really put any input arguments over here because they only matter for the very first call. But if you really want to put it just for the first time, that's okay, because you want to initialize some objects that's going to be returned for its reference for the subsequent call. That's okay. Okay, so now, so that's already set. It's syntactically, you have to learn about this keyword once. And also, it's going to be the body of the computation and returns a computer result only for the first time, right? You can see the first time here is a key, okay? For all the subsequent call, the result is simply just cached. The reference is cached. Okay, you can read the description over here. We already illustrated it. So now, how does this help us to really create the singleton pattern? Well, very briefly speaking, for whatever data objects, like a bank data you want to share, you want to make sure the method or the routine that returns the bank data objects is going to be once. So that means it's always going to return back to you the reference of the same shared objects. That's conceptually the idea. But once we put everything together into the singleton descent pattern later, I'm going to illustrate to you once more. But for now, you have to understand how the once routine as opposed to the non-once routine, how they differ from each other. Okay, so let me pose a question to you. How is the once routine in IFO different from the static methods in Java? Is it possible to approximate the once routine using the Java static methods? Is it possible? It might be possible. Okay, you might know at least one or two solutions of doing it, which I'm going to discuss briefly with you. However, it may not be as nice as a design solution, as I will argue. And especially we want to talk about, again, cohesion. Okay, let's talk about two different solutions to approximate the once routine using, let's say, the static methods in Java, which you know already from the previous OOP course. Let's now present some solution here. Solution number one. Let's say we have a class called bank data. So that's the data to be shared. So we simply got interest rate just for simplicity. And then we got some mutated method over here for modifying the interest rate. So that's one class. And for separation of concern, we got another class just for the access. And we got static over here. We got three static entities over here. We got static attribute boolean to see whether it's the very first time you're calling that particular get data method. And we also got the data itself. And we want to make sure you only create a new data object for the very first time. But for all the subsequent calls, we're going to return just the same reference. And then we got the get data over here, right? You can read this logic over here, and then I'm going to illustrate to you that it works, okay? Okay, and then we got another class over here, which is the clients of the sharing pattern over here. So we can say data will simply just be calling bank data access over here by calling the get data. Okay, depending on whether it's the first call or all the subsequent calls, you're going to return the same object over here, right? Okay, let's see how things work very quickly. Okay, think about in this way. We know from the Java course that if you say something that is static over here, especially static attributes, that means they are shared among all the instances of the same class. So what I will do is I'm going to say put it over here. So we got this particular attribute is called init once. We got another object over here that's also global, right? Think about statics like a global variable. And also we got data. And the data over here is also going to point to some reference, right? So these are independence of any bank data access objects. So now let's say this. If you're trying to call bank data access.getData for the very first time, so this is the first call. Let's see what's going to happen here. Oh, by the way, initially, of course, if you leave them uninitialized, it will simply just be false, right? For the Boolean variable, the default value will just be false. And then for data, it will simply just pointing to null, default value. Okay. So now let's say we call this bank data access for the first time, get data. When we call that, so now first of all, think about the init once over here is simply just false. Not false is going to be true. That means we're going to execute the body of the implementation. And let's go over the implementation line by line. The first line over here will simply say create a new bank data objects. So we'll do it here. So it's going to be a new object here, bank data. And as we can see from the declaration over here, bank data has just interest rate. I'll just say IR for short. Interest rate. And then initial value maybe 0.0. And then we're going to assign the address of this particular object to data. So data here, rather than pointing to null, is now going to point to this particular bank data, right? So that's the initial, the very first time you call that static method, get data. And then init once is going to be modified to true. Init once, rather than false, is going to be true, meaning that all the subsequent call is going to follow a different branch to have a different behavior. We'll see. Okay, and then finally we'll simply return the data over here, and then the data is simply pointing to this particular data object over here, right? Just return the reference and then reassign that to this data here. Just don't get confused. We got data here and also data here. They're different. Okay, so that's the very first call for this static method over here. What about the second call? Quickly, if I try to call, let's say bank data over here, access dot get data. Basically, this will be considered a subsequent call for sure. Okay, so this will be, for example, the second call over here. Right, that's a subsequent call. What's going to happen here? So we're still going to execute. Let me use a different color over here. Let's say get data for the second time. So we're still calling this particular method, but now the init once has been set to true. So not true is going to be false. So that means we'll simply bypass this particular fragment of code. We'll simply just return the data. And what do we return? We'll simply just return this particular reference over here. And then, so that means this data here, let's say we also say data is assigned to, right? So now in this data, it will just be assigned to just the same object over here. Right? So you can see we're just approximating how the Java static methods can work just like a once routine. But you can see they're not exactly the same. You have to introduce some global variable over here to regulate the first and versus the subsequent calls to the static methods get data over here. Okay, so that's about the first solution over here. So let's move on to the second solution. Oh, actually, for the first solution, is this a good way to actually do sharing between objects? So I already showed you this solution actually works, but is that a good design solution? That's the question. Okay, is it? So maybe you want to pause the video and think about it, and I'll give you one hint, which is does it really ensure a single instance for the bank data? Does it really ensure? Okay, so assuming that you have already paused the video and thought about it, okay, so the real problem for this particular design over here, let me just say what the problem is. Sharing is not enforced. It is not guaranteed. And if I claim that it's not working, I need to give you a witness, like a counter example. Very easy. Okay. The example I can give to you would be, because the bank data constructor over here is simply just public. Meaning that, yes, I can definitely try to create this particular new bank data objects in a control way using init once, but it doesn't stop me from simply just go for example, I'll show you here. You can see from the slides over here, I can simply just have another class over here. Let me just call it account. It's a different class, and then I can simply say data is assigned to new bank data. So now you can see the new bank data over here and also the new bank data over here. There's simply two separate calls to the constructor over here. So we are really creating more than one objects for that bank data. So there's no sharing of a single instance. So that's the problem. The problem is the constructor over here is simply just public. You cannot stop from any clients from calling this particular constructor. So that's the issue. Okay. So the first solution there, even though unless you can assume that your clients will also call get data to really get the data, but I don't think that assumption will work. That's too strong assumption. Otherwise, this solution is not working because you cannot guarantee there's only a single instance. What about the second solution? The second solution was simply say, well, since we don't want anybody to actually call this constructor except for this particular bank data access class, why don't we merge this part over here into over here, and then we can make the constructor private, meaning that no other client classes can call this private constructor. That's the rationale. Why don't we take a look? Okay, so you can see this is the second solution over here. Okay, let me show you quickly. So that's the second solution. You can think about we have just one single class called bank data over here. And then you can think about it can be divided into two parts. So this part over here is really about the data. Okay, you can see the bank data private constructor and also its attributes and also its mutator, right? So that's the first part. What about the second part? The second part over here, as we spoke about before, this is really about the access, like sharing access to that particular data. So we're putting data and also access into a single class. Okay, you can really try to convince yourself it's really still working by following the same runtime tracing I did previously. I'm not going to waste your time on that. Okay, you can just confirm yourself, or you can ask me during the Q&A about the second solution. But now, is this a good solution though? Well, hopefully you can realize we are really trying to merge two things into a single class. Data and data access are really two different purposes, and we are putting that into a single class. So it's really violating the cohesion design principle. It's violating cohesion. Cohesion over here. So that's really violating it because you got data and also access into the same class. So it's a violation. So now, it seems like in Java, it's like a dilemma. Either we have to separate the concerns about data access versus the data. But if we do that, this particular public constructor for the data will allow other client class to create separate instances, which will break the sharing. So either we have to sacrifice the sharing, which we definitely don't, or we have to sacrifice about cohesion, in which case we simply combine all these two aspects into the same class. We actually don't want either of them. So it seems like there's no perfect solution in Java. Okay, how can we do this in IFO then? We definitely have the once routine to help us to return the single object instance that's always the same. But now, how can we solve the constructor problem over here to make sure only a particular class can call this constructor? Well, that's something we need to talk about next before we can present to you the ultimate solution, which is the export status.